helicopter squadron converges on New Orleans, flown by experienced pilots from across the Gulf Coast. Hours before the big test, they meet for a briefing.
All right, everybody, let's talk about the task at hand here. What are we trying to do? We're going to try and do something unique that no one's ever done quite this way before.
The destination is New Cut Dune, the barrier island chosen by Mark Hodges for the test.
We're going to try and accelerate Mother Nature by bombing this land with seeds of life.
If this is successful, the implications for restoration of mangroves around the world and stabilization of coastlines that continue to erode, the potential is fantastic. I think we're running out of time to solve these sorts of environmental problems. How much time, we don't know, but when you do know, it's too late.
Each of you can have about 1,300 canisters in a bucket hanging underneath your helicopters. Jennifer, who's filling those buckets up right now, is going to be in helicopter number 1 with one of you guys. We've got 20,000 canisters to deploy. Mark and I are going to be on the ground. We'll measure the canister impact patterns after the bombing run. Kevin is going to be in the Alpha helicopter. He's on overall observation.
Kevin's also in charge of timing. He'll order each helicopter to drop its canisters in a sequence to achieve maximum coverage of the target zone. The goal is a simultaneous drop from 4 choppers, the world's first attempt to reforest black mangroves from the air. Basil sets up a windsock to mark the beginning of the drop zone.
A windsock in sight.
If the pilots maintain formation and Kevin gets the timing right, the run should result in a forest pattern about 60 meters wide and over 300 meters long. Conditions are perfect. The winds are less than 8 kilometers an hour.
Okay, get back in the formation. Upper 4, down a little bit. That's it.
Now, do you want to continue to move?
Come on. Drop it. Let it go. Nothing fell out.
What is the problem?
Negative drop. Negative drop. There was no drop.
That's not good.
The buckets are opening, but the canisters are stuck inside. Saving the world from global warming has hit a snag.
I can see the pins. I can see the pins.
It's not pulling. It's not pulling the bed.
What happened? Over.
I have no idea.
The team calls a timeout.
All right, one's coming down right here.
Basil thinks faulty release pins prevented the buckets from opening.
Okay guys, helicopter 1 and 2, the pins didn't even come out.
That's right, they did.
No, they didn't.
Yes, they did. We have 4 plug toilets up there.
Those are the most expensive toilets in the world. They're flying around at a huge cost. We've got to make this work.
Jennifer finally solves the mystery.
Problem is there were a lot of broken canisters, so it created this perfect packed solid ball. I reached my hand up inside and it was solid. Nothing had made it down into the neck.
I'm a bit disappointed, to be honest with you. That delivery mechanism's absolutely rubbish.
Inside the bucket, the individual canisters are deforming, both from the weight above them and the vibrations from the helicopter. As they're compacted together, they form a single mass, too big to fall through the bucket's valve.
We need something where the bottom falls out so everything just completely collapses and comes out of the sky when it's told to.
They can think of only one option.
It's essentially a cargo net used to distribute hay over an area that's been seeded with grass seed after a forest fire.
The next morning, the team returns to the island with 4 nets.
We're running out of time, gentlemen. Let's get with it.
Now, just before the test, the pilots find themselves fighting 48-kilometer-per-hour winds.
Much windier than yesterday. This is going to make dropping the canisters so much more difficult.
As the winds increase, Mike, the head pilot, calls for a conference.
Are we okay?
The winds are right on the edge. We're getting 21 knots up at altitude. Our stop point's 28, and you guys are getting 25 down here.
That is really close to the limit.
What I'm worried about is what happens after they release. Are they flapping in the wind like a flag?
Yes, they are.
Now, is there any chance they could fly up into the rotors?
There's always a chance of that.
The pilots decide to make the drop, as long as the winds don't get any stronger. The team can only hope that when the nets open, the canisters will land far enough apart to create a healthy mangrove forest.
Aircraft are inbound. Aircraft are inbound for the drop.
Good luck, guys. This is it.
All right. This is it. This is it.
The drop.
Here we go. Here we go.
Go, go, go!
The nets open perfectly. The canisters fall bottoms down exactly to plan. And when the handmade aerial reforestation bombs actually hit the island, they plant themselves deep in the soil. But the team has a major problem.
There is not much spread there. This is not the forest I had in mind. Distribution is way too dense. They're on top of each other.
Mark knows collecting data from a failed test is often just as valuable as information from a success.
Which one's that, 34?
That was 34 and the same for 27.
The good news is that 80% of the seeds planted perfectly.
For 6 and the same for 1.
But the average distance between canisters is 30 centimeters, and it needs to be no less than 120.
They're much too tightly packed.
It's no good.
Everyone is determined to get it right.
This distribution is absolute rubbish. They're clumping together.
What do we need to do to get the fall that you want?
The only solution is going to be go for higher altitude and release under speed, say 70 knots, 1,000 feet up, and let her go.
In early tests, flying at high altitude resulted in the right impact pattern for a healthy forest. But back then, their highest altitude was just 150 meters. Here in New Cut Dune, the drop is twice as high, and so twice as unpredictable.
The problem with going higher is you majorly compromise on your accuracy, especially when it's as windy as this.
Higher altitude and gusty winds will knock the canisters wildly off course. So Basil recalculates the release point.
We're going to have to add on 165 foot to our lead distance. We're going to put the windsock about 500 foot up in that direction. You have to release the canisters there.
At 300 meters, in high winds, flying in formation is too dangerous. So the helicopters will enter the drop zone one at a time.
All right, check it out, man. Here he comes. Here he comes.
That is high. Come on.
Let her go.
Come on, Dad.